Hello, welcome back. Today we're going to look at two more examples of integration by substitution. So our first example is going to be the integral of x multiplied by 3x minus 1 dx. Okay, so the first thing is we need to find the value of u. So let's do a box. So this time we're going to let u squared equal 3x minus 1. You can let u equal the square root of 3x minus 1, however that method is slightly harder. So we're going to take the easy route. If you want, you can try and do u equals the square root of 3x minus 1. It's going to give you the same answer, but it requires more methods. Okay? So, to find dx by du, we need to find du by dx first. And by that, we need to do implicit differentiation. So, differentiate u squared, and we're going to get 2u du by dx is going to equal 3. Okay? If you're unsure on implicit differentiation, then watch my videos on implicit differentiation, and that should make sense. Okay? So therefore, du by dx is going to equal 3 divided by 2u, and therefore dx by du is going to equal 2u divided by 3. Okay, you just inverse them. Alright, so this is going to equal the integral of x times the square root of 3x minus 1 multiplied by 2u divided by 3 du. Okay? Right, so we've got x's here, well, we've got this x which we need to get rid of. So what is x in terms of u? Just rearrange this top equation and we're going to get x is equal to u squared plus 1 divided by 3. Alright, so we need to substitute x for u squared plus 1 over 3, and therefore we're going to get the integral of u squared plus 1 divided by 3 multiplied by the square root of 3x minus 1, which is just u, multiplied by u, and then we're going to multiply that by 2u divided by 3 du. Okay? Nice and easy. So we got a constant, we got 2 over 9. 3 times 3, 9, 2 over 9. So we bring that out, we get 2/9 multiplied by the integral of u squared is what we're left with, and then u squared plus 1 du. Alright? Okay, so this is equal to 2/9 multiplied by the integral of the expansion, which is just u to the 4 plus u squared Okay, this is going to equal 2 over 9 multiplied by the integral of u to the 4 plus u squared. So if we integrate that, we're going to get u to the 5 divided by 5 plus u cubed divided by 3 plus your constant of integration. Alright, so 5 and 3 share a common denominator, as you know, which is 15. So this is going to equal 2/9 multiplied by 3u5 plus 5u cubed divided by 15. Okay? Right, so I put them over the common denominator because we can simplify by putting things over common denominator. So therefore we can factorise now. So 15 multiplied by 9 is 135. So we get 2 divided by 135. Now we need to factor 3u to the 5 plus 5u to the 3. The common factor there is u to the 3. U cubed. So therefore this expression becomes 3u squared plus 5 plus c. Yeah? Okay, so we're almost there. So we've got u's. We just need to put the u's in terms of x. So let's do another box. U cubed. What is u cubed? So u is equal to the square root of 3x minus 1, which can be written as 3x minus 1 to the power a half. So therefore, u cubed is going to equal 3x minus 1 to the power 1.5, 3 over 2. Alright, so this expression now becomes 2 multiplied by 3x minus 1 to the power 3 over 2 divided by 135. And now we're going to multiply that by 3 times u squared. So that's going to be 3 multiplied by 3x minus 1 plus 5 plus c. Okay, and so there's your answer. Of course you could expand this and that'll give you 9x plus 2 altogether. Alright, so let's do another example. This time we're going to look at the exponential function e to the x. Alright, so let's take let's take the integral of 5x e to the power 3x squared dx. Okay? So let's do another box. This time we're going to let u equal 3x squared. Alright? It makes sense to do u equals 3x squared, as it's a lot easier to do that. You can do u equals 5x or whatever, but it's always good to do the exponent as u when you're dealing with exponential functions. Okay? So therefore du by dx is going to equal 6x, and of course dx by du is going to equal the inverse of 6x, which is 1 over 6x. Alright, nice and easy. So this then becomes the integral of 5x e to the 3x squared, and now we're going to multiply that by 1 over 6x du. Alright? So as you can see, the x's neatly cancel and we get a constant, which is 5 divided by 6. So we can bring that out and we get 5 over 6 multiplied by the integral of e to the 3x squared, which we're left with, and integrate it with respect to du. Alright, so this is equal to 5, 6 multiplied by the integral of e to the u, because the u is equal to 3x squared. And finally, we need to integrate e to the u, which is of course just e to the u. And we add our constant of integration. So all we need to do now is put u in terms of x, and what we're left with is 5, 6 e to the 3x squared plus your constant of integration. Okay? So there you go. In my next videos on the examples of u substitution, we will look at harder ones involving trigonometric functions and limits. So I hope to see you in that video.